Hello, my name is Arne Schleunitz and I'm the Chief Technology Officer of Microresist Technology, and I'm very happy that I can introduce you to our company very briefly and give you an overview about our products that we have available for the photonics community. Microresist Technology is dedicated to the innovation of photoresists and photopolymers as an enabler for the photonic industry, as you will see in the next slides. You are the experts, you know exactly what the photonics community is capable of in terms of manufacturing or realizing applications such as LCD polarizers, nanoscale light sources, wafer level optics, optical interconnects or optical waveguides, high brightness LEDs, diffractive optical elements, and so on. What all these applications have in common is that they require micro and nanoscale pattern. And that is exactly where our company comes into the play. With our photoresist and photopolymers, you are able to generate micro and nanoscale pattern. As you can see here in these 4 examples, or exemplary 4 examples, where you have a single layer lift-off resist, which is used in the manufacturing of optoelectronic components. We have a grayscale positive tone photoresist, which is used to generate advanced 3D structures in thick positive tone photoresist as resist masters. We have hybrid optical polymers, which are used for the manufacturing of wafer level optics, of micro lenses, of micro lens arrays, by replication technologies. And we have nano imprint materials, which are used to pattern at nanometer scale, for example, to generate high brightness LEDs for the photonics pattern sapphire substrates or nano-photonic application. Our company, in a nutshell, as I said, is dedicated to the innovation of these innovative polymers and photopolymers, which are used to generate the micro nanostructures. Our company was founded in 1993, so 20 years old. Meanwhile, successfully in the business, we are roughly 50 people here located in Berlin, and we are certified after quality and environmental management system. Our portfolio is presented here in this slide, where you see that we have negative tone photoresist, we have positive tone photoresist, we have nano imprint materials, and we have our inorganic, organic hybrid polymers. Besides, our strategic distributorship means the partnership with our partner companies, mainly from US, where we are distributing the materials here for most of the European countries. The footprint on the photonics community is mostly given by this positive tone photoresist, which is used to generate 3D structures by grayscale lithography, and our hybrid polymers, which have glass-like properties after UV curing, as I will show you in the next 2 slides, just as a teaser. This is an example where you see what you are capable of doing if you apply the grayscale positive tone, grayscale photolithography to our positive tone MAP 1200G series. Here, a few examples which were generated together with our partner company Heidelberg Instruments, which used their direct laser writing tool to generate 3D structures in a thick positive tone photoresist. The unique selling point here of our material is that you can spin coat it to rather high thicknesses, up to 100 micrometer and even higher. And based off the special chemical composition, you are capable of patterning the material down to the resist depth of 60 to 80 micrometer, or in principle, if you further fine-tune the process, down to 100 micrometer and possibly further. At least we are working on that very intensively. Second example are the hybrid polymers, which behave like a negative tone photoresist, but have very unique properties, or let's say a unique combination of properties after UV curing. They have glass-like properties. They can be processed rather fast, as it is a radical polymerization, which do not require specific heating steps for the cross-linking. Has excellent pattern fidelity from the micrometer down to the sub 100 nanometer regime, so very attractive for diffractive optical elements. And they have a very high mechanical and chemical stability, as well as a temperature stability. That's why those materials are used by our partners, as you can see here in the slide, for wafer level optics, for micro lens arrays, for diffractive optical elements, or more fancy optical components where you combine photolithography, imprint, and inkjet printing, for example. There are much more, let's say, offers that we have in our company in terms of a supplier for the photonics community. You can also think about 3D printing. You can think about printing micro lenses by inkjet printing. You can think about mix and match approaches where you combine certain technologies with a suitable material. Or if you go to the sensor application, biosensor application, also think about materials for optofluidic materials. So if I could gain your interest in our company, please visit our website, where we have a lot of technical information available, our products, and you can reach out there to us, and we are very happy to engage with you and your photonics project. With this, I would like to thank you for your time, and stay safe.